All right, so now we're taking a look at 1.2.4. How can I change fractions to percents? So we know that probability can be expressed as fractions, percents, and decimals. And we're going to look at changing fractions to percents in this lesson. So we're going to learn geometric strategies to further your understanding of how to convert fractions to percents and model this conversion. All right, so here we have for problem 185. After 25 flips of a fair coin, Lorraine and her partner recorded 14 heads. So you notice they write their fraction as 14 over 25 because 14 represents how many heads they landed on. And in this case, they flipped and landed on heads 14 out of 20 times. That's going to be our parts or our desired outcome, the outcome we're looking for. And then 25 would be how many times you flip the coin, right? And so now this first question asks, is this more than, less than, or equal to 50%, the theoretical probability of flipping heads? Talk with your partner. How do you know? Well, if I'm going to try to get this out of 100, right, because percent means 100, then I would need to change my total to, what do you think? 100, right? So here I'm writing an equivalent fraction. And what do I have to multiply 25 by to get to 100? Because we're writing an equivalent fraction, right? So I'm going to write an equivalent fraction to 14 over 25. Well, I can figure this out by saying how many times does 25 go into 100? You can think about how many quarters go into a dollar. That might help you out. So it goes in there 4 times. So I'm going to multiply 25 by 4 to get to 100. Then I'm going to multiply 14 by 4 to get to 100, excuse me. So see 14 times 4, that's going to be 10 times 4, that's 40. And then 4 times 4, that's 16. Add 40 and 16 together, we get 56. So this would be my percentage because notice it's out of 100, it's over 100. So 56%, is that higher or lower than 50%? Higher, right? 56% is higher than 50%. So we just explained how we knew. So percentages are one way to compare the different portions of the total. If you have not already done so, work with your partner to calculate what percentage of Lorraine's flips were heads. Be prepared to share your answer. We already did that, so we don't have to worry, right? 56%. Now we're looking at 86. Damar also kept track of the number of heads he flipped. He wrote his experimental probability of flipping heads as the fraction 7 over 20. He wants to rewrite 7 over 20 as a percent. So to do so, he needs to rewrite it as a portion of 100. He started by drawing the picture at the right to represent 7 over 20. So as he looked at this picture, Damar realized that he could adjust his drawing to show 100 parts instead of 20 parts. How many 100 parts are shaded? Explain your reasoning. All right, so here's his new diagram that he just drew. How many of these parts are shaded? Explain how Damar can use his new picture to write 7 over 20 as a percent. So here it's out of 20, and this new picture is out of 100. Think about what percent means. That might be your reasoning. Use a similar strategy to rewrite 3 over 10 as a percent. Show your steps. Again, we want to get that denominator go from 10 to 100, and we can write it as a percentage. So how can we get from 10 to 100? What operation would we have to do? And then remember, we have to do that same operation with our numerator or our part so we can keep the fraction equivalent, right? We want the probability to stay the same. Next, we're looking at Randy, who's playing double heads, a game in which he could flip 2 coins at a time. He recorded the number of times he flipped two heads at the same time. He flipped the coin 50 times, and there were 20 times when both coins landed heads up. He recorded his data as 20 over 50. How does 20 over 50 compare to 50%? So again, we're comparing it to 50%, but this time we have 20 over 50. And again, I'm going to want to do that same thing, right? I want to get my fraction of 20 over 50 to equal a fraction over 100 because it says we want it as a percent. Percent means out of 100. So I changed that to 100, which means I would have to multiply 50 times 2. Therefore, I have to multiply 20 times 2 to get my top number. So how does my top number compare to 50%? 40 over 100. How does that compare to 50%? Then it says Randy claims that 20 over 50 is equivalent to 70 over 100 because if I add 50 to the denominator to get 100 and add 50 to the numerator to get 70, the fraction becomes 70 over 100. So now we're going to explain to Randy why 20 over 50 and 70 over 100 are not equivalent portions, meaning they don't represent the same probability or likelihood. Next, we're moving on to problem 88. It says 3 students invented a game in which they flip coins for 1 minute and then determine who flipped the highest percentage of heads. After the first round, each of them thinks that he or she was the winner of the game, and here's what they reported. Of my flips, 12 out of 25 were heads. Autumn says, I flipped my coin 10 times or 40 times, and I had a total of 18 heads. So how would you represent 18 out of 40? What fraction? Okay, so I'm writing my fractions down. Right now I have 12 over 25, and then I have what 18 over 40 would be as a fraction. And she says, since both of my numbers are larger than yours, I must have won. And then Kumar says, I reported 44% of my flips as heads. So again, you might want to put this into a fraction. And here with percentages, what is our denominator or our bottom number of our fraction? I have an idea, so I have mine written down. So I have them all written down as fractions, and now I'm comparing them. But I'll show you what I have. All right. Don't look unless you have yours done, but this is what I have right now. And I need to figure out how can I make these comparable. Like right now, 25 and 40 and 100 are not easy to compare, right? So how can I get these to be the same denominators? Or maybe I even want to calculate my percentages. How do we calculate our percentages? Well, let's see. I remember in one problem we did, if I made 12 out of 25 free throws, we did 12 divided by 25, and then I multiplied that by 100. So for my first fraction, if I wanted to get that into a percentage, you do 12 divided by 25, then take what that answer is and move my decimal place over 2 places to make it bigger, or I could multiply by 100. All right, so that's how I could get it into a percentage if I want to do that. Otherwise, if you have a nicer way to compare these, maybe I just take my decimal. I could get my decimal from doing 12 divided by 25. There's a lot of things I'm thinking about here. All right. Finally, there's 189. It says change these fractions to percents using a strategy of your choice. So first one is 13 over 20. Now this goes back to the last problem we were just talking about, where we talked about how we can get it into a decimal and then how we can get it into a percent. So let's say I'm working with 13 over 20. Is that a fraction, decimal, or percent? That's a fraction, right? Now if I want it as a decimal, how do I convert it? Well, remember that 13 over 20 is the same thing as saying 13 divided by 20. So if I go ahead and do that on my calculator here, 13 divided by 20, I get this. I get 0.65. So that would be what? My decimal, right? Because your decimal is going to be between 0 and 1, just like your fraction. But now we can write this as something out of 100. So instead of being 0.65, we can multiply by 100 or simply move this decimal place over 2 places. Either way, you're going to end up with 65%. Basically, just got rid of that decimal. So here we have our fraction. Here we have our decimal. And then once we multiply it by 100, we end up with our percentage. So you're going to convert fractions to percents for each of these fractions. All right? 2 steps. Get into a decimal by dividing, and then get into a percentage by multiplying by 100. All right, and then here we're moving on to our review and preview, the last part of the lesson. Once you complete this, you will be all good for the day. Remember, I have the homework help posted, so if you're having trouble, you can always work through it with me, or sometimes I'll have another teacher do it with you, okay? Good luck.